So the title of our Chalk Talk today is Cloud Computing for Electronic Design. Are we there yet? So Craig, in order to talk about cloud computing, we really need to start with high performance computing, right? So how exactly did we get here?
The reality is that to do electronic design, it's incredibly compute intensive. And the way that we can look back and see how the highest performance computing platforms evolved is a simple graph like this one. It goes all the way back to the 40s and 50s when the first large-scale computers were actually mainframes. And what we saw evolving over time is that eventually mini computers emerged, high-powered workstations emerged, and those largely were reducing the expense of the compute. Sort of in the 90s and moving into the 2000s, the client-server model really emerged as the preferred compute approach, where a local control through a client was actually accessing higher performance compute in a server farm. And that eventually led to what today we would loosely call cloud computing. So the history for high-performance computing has really spanned this multiple decades, but it's got us to where we are today in something that people loosely call the cloud.
So Craig, what kind of cloud service I need depends on my design needs, right? How do these services and platforms break down?
Yeah, what I have found interesting is in talking to a lot of different customers, the terminology actually becomes a barrier to understanding. So a simple diagram like this one that points out what the different cloud service models are can be really helpful in understanding the macro cloud environment. And the way to think about it is really like a pyramid, where as you move further up the pyramid, you're taking advantage of services that are implemented at a lower level. It all begins at the base level, something called infrastructure as a service. And this is the foundation of cloud. And it's a model where the user brings their own software and rents the hardware from the cloud provider. And examples of these are the large major cloud providers that we're quite familiar with, from AWS, Azure, Google, Alibaba, IBM, Oracle. All of these companies offer this model. Moving one level up, the use case changes a little bit. There are often companies who want to create services or want to provide a software solution. And rather than start at the most basic level of buying a C compiler and beginning to write basic code like that, they can actually begin with a complete design environment that's cloud enabled through something called a platform as a service. So this is a way to jumpstart the creation of solutions if you're beginning with nothing to start with. And many of the same providers offer these, but there's also a few other companies who don't have infrastructure as a service who provide platform as a service. An example would be the company Salesforce. They have a platform that's based on some of what they learned as a software as a service company that they use at the platform level. And then putting all of that together, the culmination of the cloud is typically represented in something called software as a service, or SaaS. And a SaaS solution is typically one where the user is really only responsible for managing who uses the service. And the company that delivers this is responsible for all aspects of the solution itself, the software, the underlying compute, and the service and support that goes along with it. And we're quite familiar with these in our everyday business life in the companies like Salesforce, Workday, ServiceNow, Slack, even all these Microsoft applications that people use that are cloud-based are really sold as a software as a solution.
That makes sense. Now, Craig, you've been in this cloud computing arena for a long time. What have you seen are the most common cloud concerns?
The concerns differ according to what type of customer or user you are. When I break this down for a company that's doing silicon design and thinking about the compute requirements that they have, they typically ask questions like these. The primary concern is almost always beginning with security. Is it secure? What happens to my data? How much is this going to cost? It's not just about the benefit of having this huge compute pool, but it always boils down to what the CFO is willing to allocate. Many times, what happens is the companies have these big investments in their own data centers and their own server farms, often like private clouds themselves. And they need to answer the strategic question is what will happen to this compute if I try to use the cloud? A practical consideration emerges when they think about how to deploy it. Many companies have very experienced IT groups that are building and managing their on-prem server farms, but that doesn't necessarily translate to the same skill set that's needed to handle the cloud. So a company has to thoughtfully think about whether the IT group can handle it. With anything, when you move to a new type of solution, if you're going to give up your server farm infrastructure, you want to be very careful. And many customers ask what will happen. Will they get locked into one cloud vendor and then be forever beholden to what that vendor wants to provide or charge them? Another big consideration is to understand what software might be available. If something that you use today on-prem doesn't work in the cloud, that can be a big problem. And finally, from a Cadence perspective, we always talk to customers and they're almost always interested in understanding, is someone already doing this? No one typically wants to be the first. So there's a lot of concerns, and it's not a simple task about just making a phone call and switching to the cloud. It really has to be part of a strategy.
It certainly does seem like that. Okay, Craig, let's step back a sec and talk about on-site IC design versus cloud-based design. What do you see are the biggest hurdles in on-premise design?
When we talk to customers who have these large investments, there's benefits to the way that they're deployed, and there's also some issues with that approach. A graph like this, which tries to very simplistically depict what the requirement is from a compute standpoint for doing electronic design, where the red line, this wave of up and down, represents how much compute is required at any given time during the course of a project, versus the green dotted line, which is a representation of the available on-prem capacity. And what you can see happens is that the red line doesn't match what the green line has available to it. And when that occurs, some interesting dynamics emerge. Whenever the red line is above the green, what we have is an engineer waiting for compute. The reverse of that is when the red line is below the green, you have scenario 2, where the server is actually idle, meaning that there's a capital expenditure that's not being utilized. And the other interesting thing that happens is that when a company relies solely on on-prem compute and their required demand increases, they need to respond and add more capacity. And that takes time. Time in the form of identifying what types of servers to purchase, working through the purchase process itself, taking delivery of those servers, installing those servers, configuring the operating system, and finally having those servers ready to use. So that can take months, and that doesn't necessarily match the requirement of an electronic design project. So these are all hurdles and challenges associated with the historical model of on-prem compute.
Sure, that makes sense. So, Craig, how does a cloud-based compute environment compare? And not all clouds are the same, right?
You're right, Amelia. There's different ways to utilize the cloud. This simple diagram explains that any of these three models are actually possible with the cloud. Where we are today in the community is largely big companies have exclusively on-premises compute. It's really what we were showing on the prior picture, where the red line doesn't really match the compute that's available. Now, that's positive in some ways. The compute's already in place. It's customized to what a customer needs, but it comes with some issues. The capacity itself is capital expense. And that means you're depreciating it over 4 or 5 years. You have an IT team that's supporting it, and it's relatively inflexible, as we just described. It's got these issues with idle engineers, idle compute, time to deployment that can take a lot of time. That model is imperfect. So what can the cloud do to help? Well, the easiest thing is actually to jump all the way to the right-hand side and go all cloud. Why is that easier? Well, you can switch your OpEx to CapEx, and that is generally preferable to the CFO. It's also very resource efficient. If you look at the depiction, the blue exactly matches the red, meaning that you're never really paying for compute that you didn't use. The challenge, though, is that that transition is tricky, especially if you're one of these companies that has a huge server farm investment. And the other thing that we hear a lot is that moving all to the cloud introduces this concern over controlling expense. The companies know that the cloud is an infinite pool of compute, and their worst nightmare is that an engineer over the weekend somehow consumes 3 weeks worth of compute budget by launching something, incurring a huge cloud expense. So those are some of the mitigating factors. A little bit like, the Goldilocks, too hot or too cold or just right. Hybrid cloud is kind of in the middle, and it's very attractive for its agility and scalability. It's an incremental change. The companies don't have to get rid of their on-prem environment to use the cloud, but it comes with some significant challenges. You still have all of your issues with your on-prem support that you need to deal with. When you begin using the cloud, you've just introduced new skills and requirements and knowledge that your IT group will need to have. And the tricky thing actually turns out to be data management. When you're either all on-prem or all in the cloud, you don't have to really worry about extra copies of your design floating around. Once you're trying to do some work in 2 locations, you have to make sure that you're working on the right version of the data every time that you use the cloud or your on-prem environment. So it's not straightforward. There's no one right solution, but you can see that there's a lot of factors that would go into making that decision.